This is the reading guide for the Hawaiian Petrel paper by Anne Wiley from 2013. This is a really well-written article, and I think you'll find it pretty easy read. Throughout the article, they are very clear to connect this work to its broader importance, and then they also do a really good job as they write of explaining alternative hypotheses and explaining why they think the evidence supports the hypothesis that they're putting forth. So as you read through here, obviously the beginning is going to tell you about the previous work that's been done. You guys are pretty familiar with how to find that. As you move a little further in, results and discussion, this is a section where they start to give different explanations and explain why they think they're seeing what they're seeing. So they're talking here about nitrogen, for instance, and why they're seeing the elevated nitrogen levels that they see. And then they choose a hypothesis here. So that's a good section to really look carefully at the evidence and do you agree with what they're saying? Are they making a strong enough case? There are two figures here of interest. This shows the range map for the Hawaiian petrels, right, that they existed at one time at least on all of the large Hawaiian islands. And then they show the stable isotope graph here, right, for nitrogen and carbon, and they're separating out hatch year birds from adults. So hatch year birds have these diamonds. You can see Maui and Kauai here on the left, and here's the Hawaii hatch year bird. This is a pretty interesting chart here in that you can see there's such a difference between the three different hatch year birds that they have. And then they also, I want to point out what this blue is. There's a blue circle here, and then there's a blue circle on the inset A. That corresponds to an area, well, at least the blue inset here corresponds to an area with elevated nitrogen levels within the ocean. So animals feeding in that area will also incorporate higher levels of the nitrogen stable isotope. And so these birds are circled here in blue as being birds that are potentially feeding in that area. There isn't a whole lot to say about this paper because it's pretty well written. For figure 3, I'm going to point out that the numbers here next to each point on this graph are the sample sizes. That becomes important because as they want to look and see if these changes or declines in nitrogen over time, nitrogen 15, are significant or not. And so you can see that modern samples, of course, they have a lot more specimens, right? There are 15 in this group, 12, 30, and as you can see here, we're on, well, okay, this axis here is time. So modern time period is here on the right, and ancient prehistoric time is here on the left. So modern samples, of course, they have many more, and then ancient time periods they've lumped. So each one of these numbers here, for instance, this 10 for Hawaiian birds, this represents individuals that were potentially sampled across, 300, 400, 500 years. So while they're being plotted here at this time period, it's not that they're all exactly from that 1 year. So that's something to keep in mind. And they do have error bars in terms of time that reflect the carbon dating that they've done on these subfossil specimens. So now when you want to figure out significance, right, because you see this trend, but they explain very clearly that they've just put dotted lines connecting these points for the different islands, individuals found on the different islands. And so while this red down here from Maui looks much lower than this one here in the previous time bin, are these values for nitrogen actually statistically significant? And so I'm going to refer you here to the supplement in how they looked at that. They say within the text as well that they looked at it with the Tukey honestly significant difference. Here we go. And so they did that for the different islands, for each group within each island. And when you use a Tukey test, this is basically a t-test. It's almost exactly the same thing. The reason you would use it and why they used it is because they have unequal sample sizes. You remember there are many more individuals in the modern time bins than in the ancient time bins. And so for each time bin, there are different sample sizes. The Tukey test does require that each of the samples within each time bin is an independent test, which means it needs to be a different bird. You can't be looking at 5 different bones from the same bird and calling them different samples. They need to be independent. That's true of a t-test as well. The range of values within the time bins also needs to be about the same for each group that you're comparing. And there's one other, here's a sheet that I made out to explain these differences or explain what the Tukey t-test is. The other idea is that, where is it? Oh, the normal distribution. So in most cases in biology, you require a normal distribution. So for each group where you're testing, the distribution of values for nitrogen must be distributed along a normal distribution. So back to here, what they've done is they've put the comparisons, right? They've put these Tukey values for each comparison for each time bin for each island in table S2. So the Tukey test is just like a t-test in that you're looking for a p-value of less than 0.05. So they've put asterisks by things that are significant. And I would invite you to look at these and see which comparisons are significant. They tell you that that one is the modern time bin. So here's Lanai from modern time bin. Here's Lanai from an older time bin. 5 is the earliest pre-human time bin. So 4 is a time bin that has humans in it. So let's see if Lanai is significantly different, right? So Lanai in 4 is significantly different than Lanai 1. Okay, so we do see some significance there, at least for the Lanai sample, and I would invite you to look at the other comparisons and see if you do find significance. So let's go back here and look at Lanai. Here's green. Lanai is green. There are 5 samples, and then Lanai is green down here, 15 samples. So you can see here versus here, significantly different. I don't really have much else to say about this paper. I wanted you to understand the statistical tests that they were using. I want you to pay attention as you're reading to the different types of hypotheses that they're putting forth. And we'll come into class and we'll talk about it as a group. Actually, I do have something else to say. In the materials and methods, I would invite you to skip over the stable isotope and accelerator information. All you really need to know, right, or what might be relevant to you, is that they used an elemental analyzer with a mass spec. So there we go, which is something that we've read about before. So you do need to read the rest of the results, of course. And you're going to want to pay attention to things like how are they addressing climate change. That's something that we know you need to address when you look at historical samples. And then you also want to make sure that they're looking at variance within samples and other things that we've talked about as being potential issues or confounding factors in isotope studies. So you can find some of those in their methods. All right.